In 2023, 5 people died when their submersible imploded at 3,800 meters below the surface. The pressure crushed them instantly. There was no time to feel pain, no time to understand what was happening. One moment they were descending toward the Titanic. The next, they simply ceased to exist. What I'm about to show you is 3 times deeper than that. There's a place on our planet where the pressure turns steel into crumpled paper, where creatures exist that defy every law of biology we thought we understood, where darkness is absolute, temperature hovers just above freezing, and we've explored less than 0.05% of the entire area. We know the surface of the moon better than this place. We've mapped distant galaxies in higher resolution. But this alien world, it's right here, 7 miles beneath the waves you could swim in. And what lives there will change everything you think you know about life on Earth. Good afternoon, everybody. My name is Thomas, and I'm thrilled to bring you along for this journey into the abyss of the Mariana Trench. What you're about to see will challenge everything you believe about the limits of life. So buckle up. We're going deeper than almost any human has ever gone. We've accomplished incredible things as a species. We've sent robots to the moon, photographed black holes 53 million light years away, detected gravitational waves from colliding neutron stars. But right here, on our planet, beneath water you could swim in, beneath oceans crossed by ships every day, there's an alien world we barely understand. The story begins on March 23rd, 1875. The HMS Challenger had been at sea for nearly 4 years on what seemed like the most boring mission imaginable. Map the ocean floor, drop a lead weight on a rope, wait for it to hit bottom, pull it back up, measure. Again and again and again. For 4 years, the result was always the same. 3 kilometers, maybe 4. The ocean floor was flat, featureless, covered in thick mud. It was the most boring surface anyone had ever mapped, until this day. They were in the middle of the Pacific Ocean, 2,000 kilometers east of the Philippines. They dropped the weight, expecting the same result they'd gotten hundreds of times before. 3 kilometers. Nothing. The rope kept unspooling. 4 kilometers. Still nothing. 5. 6. 7. The crew started panicking. They kept tying on more rope, deploying every meter they had on board. And beneath their thin wooden hull, the lead weight just kept falling into darkness. Finally, it hit bottom. 8,184 meters. Over 5 miles straight down. They had found the Mariana Trench, and 200 kilometers west lay something even deeper. The Challenger Deep. 10,935 meters. You could drop Mount Everest into this hole and it would vanish. The peak would still be 2 kilometers underwater. But this isn't just a hole. This is a crack where Earth is tearing itself apart. The Pacific Ocean floor, after 170 million years of cooling, has become so dense that gravity is pulling it down. When it reaches the Philippines, it slides beneath the younger plate, bending solid rock kilometers thick, creating the deepest point on our planet. The forces involved are almost incomprehensible. Slabs of rock the size of continents, several kilometers thick, being bent and shoved into the Earth's mantle. The friction generates massive earthquakes. This is the Ring of Fire, where 90% of all earthquakes occur. But geology isn't why we're here. We're here because of what lives down there, in conditions that should make life impossible. And that's the part that kept me awake at night. Because depth isn't the scary part. The pressure isn't the scary part. The scary part is that life found a way. Let's descend. I'll show you exactly what happens at each level. What you'd see, what you'd feel, and what would kill you. We start at the surface. Warm tropical water, bright sunlight. Dolphins, tuna, sea turtles. This is the ocean you know, but this zone represents just 2% of the ocean. Every beach you've swum at, every aquarium fish you've seen, all in this tiny surface layer. At 200 meters, something changes. Temperature drops from 25 degrees Celsius to 8 degrees Celsius. But as sunlight dies, another light appears. Bioluminescence. Living light. Fish flash patterns at each other. Jellyfish pulse with blue light. Squid leave glowing trails. It's a slow-motion light show in the world's largest dark room. This is the Twilight Zone, and it teems with life. The biomass here might equal the rest of the ocean combined. The most abundant vertebrate on Earth lives here. The bristlemouth. 8 centimeters long, weighing about as much as a grape. There are quadrillions of them. More bristlemouths than all humans, all livestock, all pets, all rodents, and all other fish combined. By orders of magnitude, and most people have never heard of them. 1 kilometer down. Last sunlight. Gone. Temperature, 4 degrees Celsius. Pressure, 100 atmospheres. That's 1,500 pounds per square inch. Outside this submersible, your lungs would collapse in seconds. Your ribcage would crack. You'd be dead before you could inhale water. Welcome to the midnight zone. And this is where things get truly strange. Some fish have eyes so large they take up half their skull. The owlfish can detect light 100 times dimmer than humans can. They're hunting in what looks like absolute darkness. Then there's the barreleye. Its eyes aren't where you think. Those dots on the front? Nostrils. Its actual eyes are inside its transparent head, tubular organs pointing straight up, allowing it to hunt from below. And yes, its head is transparent. You can see its brain. Others abandoned vision entirely. The small-eye snipe eel has eyes so tiny they're almost vestigial. Some deep-sea fish have no eyes at all. Instead, they evolved lateral lines that detect the tiniest movements in water. They hunt in complete darkness with perfect accuracy, using senses we can barely comprehend. The anglerfish is probably the most famous. That glowing lure? A modified spine filled with bioluminescent bacteria. The anglerfish farms these bacteria, using them as a living fishing lure. Anything that swims toward it gets eaten by jaws that open 180 degrees. And the males. Females can grow over a meter long. Males, 3 centimeters. When a male finds a female, he bites onto her body and never lets go. His tissues fuse with hers. His bloodstream connects to hers. Eventually, he loses everything except his reproductive system. He becomes a permanent parasite, a sperm-producing appendage. Multiple males can attach to one female. It's one of the most bizarre reproductive strategies in nature. The deeper you go, the bigger things get. Deep-sea gigantism, giant squid, giant isopods, giant spider crabs with legs spanning 4 meters. The giant squid has eyes the size of dinner plates, 30 centimeters across. The biggest we found was 13 meters long. But scars on sperm whales suggest much larger ones exist. We just haven't found them yet. At 3 kilometers, you notice something disturbing. That marine snow? Those tiny particles of food floating down from above? Gone. Everything edible has been eaten. We're in the ocean desert. Down here, some fish go months between meals. Their metabolism has slowed to a crawl. They hover in darkness, barely moving, conserving every calorie, waiting. The pelican eel is all jaw, enormous, hinged jaws that can unhinge to swallow prey larger than itself. It's a swimming mouth, optimized for not letting any meal escape, regardless of size. But we're going deeper, past 4,000 meters, past submarine limits, past most research. We're entering the Hadal zone, named after Hades, the Greek god of the underworld. 6 kilometers down. Pressure, 600 atmospheres, 4 tons on every square inch. Temperature, 1 degree Celsius. We're twice as deep as the Titanic. The pressure that killed those 5 people in 2023? We left that far behind, nearly 2 kilometers ago. At this depth, you'd be crushed instantly. Bone would crack, tissue would compress. You'd be dead before your brain could register pain. And yet, life. Sprawling mats of microorganisms cover the rocks. They're not using sunlight. It hasn't reached here for millions of years. They're eating hydrogen sulfide from volcanic vents, eating poison and creating life. Chemosynthesis. This proved life doesn't need the sun. Life just needs energy. Any energy and a way to harness it. This is an entirely separate food chain existing in absolute darkness. Giant amphipods swarm across the seafloor, normally rice grain sized. Here, as long as your forearm. Translucent, ghostly white with enormous antennae sweeping for anything edible. Sea pigs crawl through the sediment. Translucent pink sea cucumbers with leg-like appendages. They look like something a child would draw if asked to imagine an alien. This is the Mariana Snailfish, the deepest fish we've found, 8,178 meters. It looks like it's melting. Its body is mostly water and gelatin. No scales. Barely calcified bones. It evolved to be almost liquid because solid structures fail here. And here's the strange part. If you brought it to the surface, it would die. Not from temperature or oxygen, but from lack of pressure. Its body needs that crushing weight. Without it, it would literally dissolve. There are creatures that would die in the air you're breathing right now. Then we find something impossible. A xenophyophore. It looks like a lumpy blob about the size of a grapefruit, except it's a single cell. A human red blood cell is 7 micrometers across. This organism is 20 centimeters. That's 30,000 times larger. It's like comparing a mouse to a blue whale. According to every biology textbook, this is impossible. Cells have size limits. As they grow, volume increases faster than surface area. They can't transport nutrients fast enough. The cells should die. But the xenophyophores never read those textbooks. They evolved complex internal structures that allow them to transport materials across their massive bodies. They broke the fundamental rules of cellular biology, and they're thriving. This is what I mean about learning about life itself down here. These creatures are showing us that rules we thought were absolute can be completely rewritten. But we're not stopping. We're going to the absolute bottom. The Challenger Deep. 10 kilometers down. Pressure, 1,000 atmospheres. 15,000 pounds per square inch. 8 tons pressing on every square inch of the submersible. Put a school bus on your thumbnail. That's the pressure. We're inside a titanium sphere with walls 12 centimeters thick, and we can hear it creaking. In 1960, 2 men made this dive, Don Walsh and Jacques Picard. At 9,000 meters, they heard an explosion. One of their viewing ports had cracked. They discussed turning back. Instead, they kept going. 2 more kilometers, with a fractured window. In a tiny metal ball 7 miles underwater, they touched bottom at 10,911 meters, stayed for 20 minutes, and they saw something that changed everything. Life. They reported seeing what they thought was a flatfish moving across the sediment. Life. At the absolute deepest point on Earth, where every scientist had said life was impossible. 53 years passed before another human reached here. In that same time, over 7,000 people summited Everest and 12 walked on the moon. In 2012, James Cameron made the first solo dive. He spent 3 hours at the bottom. His description: I felt like I'd gone to another planet and come back. It looks like one. Vast plains of grey silt stretching into darkness. Almost completely flat. Almost featureless. Almost empty. Almost. Because even here, there's life. Amphipods crawling through sediment. Sea cucumbers leaving trails. Bristleworms burrowing. The sediment is crisscrossed with tracks. Something is moving. Something is living. Since 1960, only 27 people have visited the Challenger Deep. More have walked on the moon. But the Challenger Deep is one tiny spot. The Hadal zone globally covers an area larger than Australia. We've sent 27 people to one spot for a few hours each, with lights illuminating an area the size of a living room. Imagine understanding all of North America by looking at one parking spot in Denver, at night, with a flashlight. That's the level of exploration we've achieved. Most research consists of dropping cameras with dead fish, seeing what shows up. Amphipods, sea cucumbers, every time. So scientists concluded that's all that lives here. But if you put cheese in your backyard at night and film what appears, you'd see ants and rats. Would you conclude those are the only animals in your neighborhood? We found 400 species in the entire Hadal zone. 400. In an area larger than Australia, a typical lake contains thousands of species, so either the deep ocean is virtually sterile or we've barely scratched the surface. Things are changing. New technology is unlocking secrets. Better submersibles, autonomous vehicles, environmental DNA sampling that detects species without seeing them. We're finding things. New species, monthly. In 2017, scientists found fish at depths thought impossible. In 2020, a new snailfish was discovered at 8,336 meters, breaking records. And in 2019, we found something else at the bottom. Plastic bags, candy wrappers, a plastic shopping bag at the deepest point on Earth. We reached the bottom before we knew what lived there, and we polluted it before we explored it. But maybe we're ready to do this right, because what we learn matters. Those impossible single cells, teaching us how life adapts. New medicines come from extremophiles. Compounds that function under crushing pressure inform drug development. The deep ocean is a laboratory for understanding the absolute limits of life. And if we find life on other worlds, Europa's subsurface ocean, Titan's hydrocarbon lakes, it'll look like Hadal zone creatures. Dark, cold, high pressure, chemical energy, just like the Mariana Trench. Those microbes eating poison might represent how life started on Earth, not in a warm pond under the sun, but in the dark, at a hydrothermal vent. If that's true, life doesn't need Earth-like conditions, just liquid water and energy. Any energy, which makes the search for life in our solar system suddenly more interesting. The deep ocean is the largest habitat on Earth, the least explored, the most alien, and it's 7 miles down. We've returned to the surface, but you can't see the ocean the same way anymore, because now you know, 7 miles down in crushing darkness, there's life thriving in ways we're only beginning to understand. Most of our planet is unexplored. We've sent more people to space than the deepest ocean, and we're finally starting to explore it properly. Every dive reveals something new. Every sample contains unknown species. Every exploration raises more questions. The Mariana Trench is a window into the limits of life, a laboratory for impossible biology, a time capsule of early Earth. Those microbes eating poison? That might be how life started. Which means life doesn't need sunlight or moderate conditions, making those subsurface oceans on Europa suddenly very interesting. But we don't need to go to Europa to find alien life. We have our own alien world, 7 miles down, in the darkness, in the crushing pressure, and we've barely begun to explore it. There's something profoundly humbling about standing on a beach, knowing what lies beneath, knowing that deeper than Everest is tall, creatures are going about their lives, hunting, feeding, adapting to challenges we can barely comprehend. They've never seen sunlight. They've never known warmth. They live under pressure that crushes submarines, and yet they persist, for millions of years, in the darkness. What else is down there? What haven't we found yet? Are there ecosystems we haven't discovered? Species that would rewrite biology textbooks? Almost certainly yes, because we've explored less than 5% of the ocean floor, less than 0.05% of the Hadal zone specifically, and every single time we've found something new, something unexpected, something that expands what we thought was possible. What happens when we explore the other 95%? When we develop technology to stay down longer to cover larger areas, I think we're going to discover things that change everything. New medicines, new materials, new insights into how life began, new possibilities for where life might exist. We're going to discover that life is more diverse, more resilient, more creative than we ever imagined, that the impossible happens every day beneath the waves. The next time someone asks about the final frontier, tell them about the Mariana Trench. Tell them about single cells the size of grapefruits. Tell them about fish that would dissolve in our air. Tell them about creatures hunting in absolute darkness. Tell them the most alien place we know isn't on Mars or Europa. It's here. Right here, 7 miles down. The abyss is vast. The abyss is dark. The abyss is waiting. And now, finally, we're beginning to explore it. Somewhere in that darkness, in those crushing depths, there are answers to questions we haven't even thought to ask yet. Answers about life, about adaptation, about survival, about possibility. The abyss stares back at us, and what it shows us might change everything. It's closer than the moon, more alien than anything we've found in space, more extreme than any environment we've created in a laboratory, and it's right here, waiting, 7 miles down. The question isn't whether we should explore it. The question is, what took us so long? If you enjoyed this deep dive, absolutely no pun intended, I highly recommend you do check out some of our other videos, which you'll find somewhere on the screen here, I believe. If you have any questions or curious feedback, we'd highly appreciate you let us know in the comments below. It's always fascinating to connect with like-minded souls all over the world on these strange and wonderful topics we explore. so don't hold back. Here on the channel, we are a team of die-hard explorers of space, science, the mystery of life, and everything in between. Let's get curious together, and hopefully we'll see you in the next one.